I think it's already late, so we start the section. We can see we can discuss only lecture 1 to 5 by Professor Ashoke sir, IIT Kanpur, Turbulent Combustion Theory and Modeling. As I already said, my name is Sumit Sagar Hota. I am a PMRF PhD scholar, IIT Palakar, and I am also doing this TDT. I get this opportunity of TDT by NPTEL under IIT Kanpur by under Dr. Ashoke sir in IIT Kanpur. Okay, let's don't waste much of the time. So I also solve these questions. All are mostly based on the prescribed textbook and Introduction to Combustion, Concept and Application, 3rd edition. Okay, and 2017 is the date. So now the thing is, we will solve some of the problems. All the problems are mostly from chapter 2. So what I will do, I will do the problems. The questions I already prepared. Now I have to solve all those problems so that it will be very much helpful for you for this section. Now the first question is, a mixture is composed of the following number of moles of various species. That is, there are different species are there. There is carbon monoxide, carbon dioxide, H2O, N2 and NO. So these species are given. Okay, and with the number of moles are also mentioned. So we have to determine the mole fraction. Also express our result as the mole percentage and as a part of per million. Determine the molecular weight of the mixture, determine the mass fraction of each constituent. So all these things we have to find out. We will just go very slowly, and we will just do our calculation. Now first of all, we have to first of all know which things are given. So first of all, I just write down. Now some of the species like CO, CO2, H2O, N2, NO, this much are I think given in the question. So now some moles are also given. Zero 0.095, 6, 7, 34 and 0.005. Okay, so now we can calculate what is total number of moles exist, which is summation of Ni is equal to, if you add all these things, we will get it is 47.1. Okay. So now we can also calculate the mole fraction as well as mass fraction from these moles, because we have the mole of individual species, and we also know what their mass and individual, everything we know. We all have all the information. Now the thing is, now we just have to calculate the Xi and Yi as we discussed in the lecture. You know very well. So I assume you are knowing, because all these things are already covered in the lectures. So I already calculated, so I am just to directly write down. In some of the next question, I will show exactly how it's done, because this is a long question. I directly write down all those values I already calculated and verified. I am just to write down all those values. You also note down all these values. So when you calculate also the total number of moles on all these things, we obviously we know according to the theory, it should be equal to what? It should be equal to 1. Okay. Now we have to calculate the xi, because in the you see in the what exactly they want, determine the mole fraction of nitric oxide, okay, in the mixture. Also express your result as a mole percent and as part per million, that is ppm. Okay, so now I am calculating. Now xi is equal to ni by, now I told I will tell you detailedly how I just calculated all these values. So you see how I am calculating for this species. Similar approach you have to follow for other species. Now ni is the number of moles and summation of ni is the total number of moles. Okay, so now the value I already calculated all those values. What is a number of moles of this I already given with the values. So now the value should be, total number of moles is 47.1, we already calculated. Okay, now the values comes out to be 106 into 10 to the power minus 6 kilomole per kilomole of mixture. Okay, similarly we can also calculate what is the mole percentage, which is equal to xi into, it's very important formula you have to remember. So if you calculate it, it comes out to be, because this value already know, just you have to multiply 0.0106 percentage. Okay, now what is ppm, parts per million? The formula is xi into 10 to the power 6. Here I is what? I is NO. So x of NO into 10 to the power 6, which is 106 ppm. Okay, now we should that it I think completed the A bit, that is all the things I already calculated. Okay, determine the mole fraction, everything I think calculated. Now I'm going to the B bit, determine the molecular weight of the mixture. Okay, for the interruption. Just now again, so just here we can again solve it. Okay, from the B bit. So now we have to calculate the molecular weight of the mixture, which is all the constituent species molecular xi into their molecular weight, that is their mass fraction and their molecular weight, and it can be written like this: xco, molecular weight of CO plus x of CO2, sorry, okay, x of CO2 So these are all the constituent species. I just write down all their x. Just I multiply, simple thing, simple. I only just multiply their mass fraction as well as their molecular to get the molecular weight of our mixture. Now since we have all the values, we just have to put all the values and we just easily calculate all the mass fraction, just molecular weight of the mixture. Just a second. I think now the molecular weight of the mixture comes out to be 28.6 kg per kilomole of mixture. Okay. Now we go to the C bit. Now as the C bit mentioned, determine the mass fraction of the each constituent. Okay. So this is very simple. What we will do, we do yi is equal to xi into molecular weight of I divided by molecular weight of the mixture. Okay, so we can calculate y of CO is equal to 0.002 28.01 is molecular weight of CO, 28.6 molecular weight of the mixture gives to 0.002. In the similar manner, if you calculate all other things, then the values come out to be 0.195. Y of H2O is 0.094. Y of N2 is 0.707 and Y of NO is 111 into 10 to the power minus 6. Okay, now let's move on to the next question. It should be noted that all the questions are from the chapter 2 of the SR Introduction to Combustion, 3rd edition book, Magritte 2017. So all the questions are from chapter 2. You can check all the questions are there. So some of the questions I just solved, and those questions are all related to your work, mostly related to our lecture 1 to 5 subjects. All are mentioned here. So let's proceed further for the third question. So now in this question, consider a gaseous mixture consisting of 5 mole of H2 and 3 kilomole of O2. Determine the H2 and O2 mole fraction, the molecular weight of the H2 and O2 mass fractions. Okay, so now in this question, I have to write down what are the all things given. Okay. Okay, now 5 kilomole of H2, 3 kilomole of O2. Okay. To find now we need to find x of H2, x of O2, okay, molecular weight of the mixture, y of H2 and y of O2. Okay, now x of H2 is equal to 5 divided by 5 plus 3. How I know? Because it's already written 5 kilomole of H2 and 3 kilomole of O2. Okay, because total number of moles is 8. Then we only calculate, it's coming out to be 0.625. Okay, because total number of moles is 1. So x of O2 should be 1 minus x of H2, which is 0.375. Okay. Now molecular of the weight of the mixture. As I already calculated molecular weight, so you know the formula. Directly I am solving xi of summation of xi into molecular weight of y. Since your two species H2 and O2, so for two species we write down this formula. So now we have to calculate the yi. We know the form from the concept, we know from the lectures. Y of H2 is equal to 0.625 2.016 divided by 13.26, which is 0.095. So what is now y of O2? 1 minus y of H2, 0.905. Okay. So now this is done. Let's go for the next question. In this question, what are the things given? We just write down. N2 and argon mixture is there with N of N2 is equal to number of moles of N2 is equal to 3 times of number of moles of argon. This is given. T is equal to 500 Kelvin given. P is equal to 250 kilopascal given. Okay, this much I think only given. To find x of N2, x of air, molecular weight of the mixture, y of N2, y of air, n of N2 by summation of volume. What is this thing? You know, it's written the molar concentration of N2 in kilomole per meter. That is this thing is that is. Okay, now you just proceed for the solution. Okay, so now I calculated x of N2. Similarly, you can also now x of N2 and air both are there, only two components. So how should you calculate x of air? 1 minus x of N2. What is this value? This value is 0.25. because this is already we get 0.75. Okay. Now similarly we again calculate the molecular weight of the mixture. Okay, for N2 and R1 directly I write down the values, because I already 2 times I already write down the what is the formula of molecular weight of the mixture. You should directly understand. This is the molecular weight of the mixture. Then we calculate Y of N2. I told already what are the things we need to calculate. Okay. Similarly, Y of AR is equal to 1 minus 0.678, which is equal to 0.322. Okay, this is the formula for Y of N2, and this relation already solved in the class. What is the relation between the Y of N2 and X of N2? Y of Yi, Xi, and molecular rate of I divided by molecular rate of the mixture. This is a very important formula, you should remember. Now, after completing this thing, we need to calculate that in N of N2 divided by V. Okay. We know the ideal gas equation, which is this is volume. Okay. I mentioned this for the velocity and this for the volume. Okay. N of N2 RUT okay. Just a second. Okay. Now, we know what is the P of N2. Okay. The formula we know. Okay. We don't know what is P of N2. That's the reason we need this formula, which is X of N2 into P. What is P? P is the total pressure. Okay. Now, directly write down what we need. That is N of N2 divided by volume. Okay. number of moles, N of N2 means number of moles of N2, okay, which is, this we take X of N2 into P divided by Ru into T. This is from this formula, okay, and just calculate it, all the values you just, sorry, 0.75 into 250 divided by 8.31. Actually sometimes it's 4, sometimes it's 5, so better to take 5 because most of the books it's 5. So 8.315, this is RU value. You should know all this thing, familiar with all this thing, I know, I am assuming all this thing, okay. Up and to, okay, now we get our requirement, this thing we need, so we get it. Now this problem is over. Now next, move on to next problem. Now in this question we have to see what are the things given. CO2 O2 mixture with X of CO2 given 0.1, X of O2 given 0.9, okay, and T given 400 Kelvin, okay. Now to find the standardized enthalpy of the mixture, okay, we have to find out what is the standardized enthalpy of the mixture. Now we have to do some assumptions like ideal gas behavior. This is an important assumption in mostly all the problems. And how I am writing, you should also know how you should approach one problem. This is the basic approach you have to do. So what the thing is, what I exactly done, you see this, I just show you these values, all these values already available in our certain books. All these things are available in appendix A. I write down everything, you can check everything. Appendix A of SR term. Now on, I don't write down the book name. If I write down the appendix, you should understand that from the subsequent classes, I don't write down anything. I directly write down which appendix this came from. You should assume that this is from the book SR. Okay. If it is some different book, I will tell. Now by subtracting all these things, the values we get minus 3, 8, 9, 5, 4, 3 kilojoule per kilomole. Okay. Now we just calculate H of, because I already told that what standardized enthalpy of the mixture we have to calculate. That means H of mixture we have to calculate. Okay. Now H of O2 is equal to H of O2, that is the enthalpy of formation plus the sensible enthalpy. I also done the same thing here. Here the enthalpy of formation plus its sensible enthalpy. Why there is a case of sensible enthalpy come into existence? Because the temperature is more than 298 Kelvin. What is 298 Kelvin? 298 Kelvin is the standardized temperature. It is more than standardized temperature. That's the reason why the sensible enthalpy came into existence. That is delta H S of CO2, sensible enthalpy of CO2. Okay, all these things are already covered in the classes. Okay, and we have to just here do the application. How this can be done. What is HF of O2? Why this value is 0? Because it is a naturally occurring substance. For all the naturally occurring substance, these values are 0. Okay. Natural occurring substance means already oxygen in air, already oxygen is available, like that, like hydrogen, nitrogen, all these things are, if you calculate the HF of that particular species, add the standard state, that is 298 Kelvin, it should be 0. This 0 means it is at the standard state, that is 298 Kelvin. Okay. Standard state is 298 Kelvin and 1 atmospheric pressure. Okay. Okay. Now, what we will do? We have everything. We have both enthalpy we have. Now we can calculate the enthalpy of the mixture. This is the formula. H of mixture is equal to summation of Xi into Hi, that is H of CO2 bar plus X of O2 H of O2 bar. Bar means per mole basis, per kilo or per kilomole basis, whatever. Okay, now these values comes out to be, just write down also the values, minus 3, 8, 9, 5, 4, 3. This values is already calculated. I am just substituting the values. That's it. Okay. Now I think these values comes out to be minus 36226 kilojoule per kilomole of mixture. Okay. Now this question is also done. Now we go to our 7th question. This is the only one line question, but when you see the solution, then you understand what exactly this question is. Just a second. Just a second. Okay, now for the 7th question, what is the given is the molecular weight of the stoichiometry. Stoichiometry means phi is equal to 1. Okay, you just know that for stoichiometry equivalence ratio is 1. Okay, now for the methane air mixture, we need to calculate the okay. Now what is given? Stoichiometry mixture of methane. Okay, to find the mixture molecular weight. Assumptions. Air containing 21% oxygen, and why we can because this is not exact value. This is exactly, there may be some 21 point something or like that. Okay, so we are assuming this so that there should not be any confusion. And also for one region, second region is that we are mentioning that we are doing our volume analysis. So there is two ways we are doing this assumption. Okay, here methane is there, we just write down the general equation, then we just have to put for a specific in general hydrocarbon we write down, then we automatically for methane we can do it. Means so such that this question is helpful for any kind of hydrocarbons or any kind of fuels, more practically we think. So that's the reason all the questions are very helpful. I just choose all the questions very carefully so that it will be helpful for you. Now, same expressor we just write down for the methane. That is, we just know what is methane, CH4. Okay. Then what is C? Then CXHY. What is the X and Y? X is 1, Y is 4. What is A? X plus Y by 4. That is already done in the class. Okay. It is 1 plus 4 by 4. That is equal to 2. So A is equal to 2. So just write down the expression now. CH4 plus 2O2 plus 7.52 N2 gives rise to CO2 plus 2 times H2O plus 7.52 N2. Okay. So now what we have to do? Now we have to find out the mixture molecular weight. That means what we need? We need X value and we need the molecular weight of each species. So the same thing now we only just calculate. Now what is it? From this thing we can easily find out what are the number of moles. So like that, what is the number of moles? CH4 1, N of N2 is equal to 7.52. Okay, and N of O2 is equal to 2. That is already from the equation. Everything is calculated. You can see it. Everything whatever I just taken, only taken from the equation. That's it. Now total number of moles is N of CH4, N of O2, N of N2. That is equal to 1 plus 2 plus 7.52 gives rise to 10.52. Okay. Now what is X of CH4? Can you tell? I already done this thing for many times. Simple only. N of CH4 divided by N on total, which is equal to 1 divided by 10.52. What is this value? Should be 0.095. In the similar way, I am not going to write down all these things. Directly I just write down. Okay, 2 by 10.52, which is 0.19. Just a second. Okay. Now, what is X of N2? N of N2 divided by total number of moles. 7.52 divided by 10.52. What is this value? 0.775. What will be the molecular weight of the mixture now? We have everything. Sorry. And 32 is the molecular weight of oxygen. One thing should be noted that whatever the solution I am doing, this thing nowhere available this is my own solution. I go through all this thing. So this is my own solution. Okay. So the solution may vary depending upon the person. Okay. So but the answer should be same. That's for my opinion. So you must attend the section. I see very less people are there. Nobody I think there. I don't know. So anyway, this recorded section will be also available to you. Okay. In my YouTube channel also. So no need to worry. You can go through it. Okay. So now I just calculated the molecular weight of the mixture. I already calculated the molecular weight of the mixture many times. So here also the same thing they asked. Okay. So but in a different sense. So that also we just done now. Now come to the next question. Determine the stoichiometric air-fuel ratio for propane. Air-fuel ratio. What is air-fuel ratio? Air-fuel ratio. All these things already discussed in the class. Okay. So I am not going to discuss all these things, but I just directly discuss what exactly the formula for all these things, how you should proceed for this question. These one-line questions are very important questions, and these are all conceptual questions. It will increase your conceptual knowledge to very much extent. So these 7, 8, all these questions are very good questions. Now, here given C3H8Ar. Okay. C3H8Ar mixture is there. So find stoichiometric air-fuel ratio by mass basis. What are the assumptions you do? Okay, same thing we already done. 21% oxygen and 79% nitrogen by volume basis. Okay, now quickly jump to the solution. C3H8 plus 8 times of O2 plus 3.76 times of N2 gives rise to 3 CO2. You may think how I know all these things, because I already calculated the number of moles on each atoms. What does it mean? It means that, for example, we can anyway for each species. Okay, the total number of means atoms is same, that we have to do. Okay, so for example, hydrogen is there, oxygen is there, like that. Okay, so when you calculate all these things, then you can very easily find out all this number of moles. Or there is otherwise you know how to, in chemistry classes you know basic things, how to balance equation. Okay, so by that strategy also you can try. Whatever strategy is suitable for you, you do it. Okay, these are the basic things you should know for these classes. Okay, now here already x, we know what is x and y. X is equal to 3 and y is equal to 8. And 5 we assume let it be stoichiometric. I know it is stoichiometric or not, that we have to find out. But no, actually the thing is here already mentioned is stoichiometry, but in some questions it may be written phi equal to 0.5 or like that. Yeah, okay, so that's why this formula is very very important, that it can be available for any of the things. Sometimes we assume that it is stoichiometric, sometimes we don't assume. So you see in the books the formula is only a equal to x plus I by 4. What does it mean? This means that it is only for phi is equal to 1. So for example, phi equal to 0.5, somebody want to find out the a value, then this formula can very easily used. Okay. Now the a value comes out to be 5. Okay, now what is the we have to find out the anyway airfoil ratio with mass basis. So very simple thing we have to do is, we know what is airfoil ratio molar. This is already discussed in the class. What is molar airfoil ratio? This formula we already know. If you don't know, also very simple thing. What is A plus 3.76A? You know, this is the number of moles of air. Okay, if you see it, you can easily see here that here the air number of moles is A plus 3.768 times 20. Okay, that means this is the air. Okay, so now what you have to do? What is the fuel? Fuel is 1. How you know fuel is 1? Okay, now what you have to do? You have to calculate the airfoil ratio. Simple. So what is this value now came out to be 4.76A. So now there is a relation. Okay, what is the airfoil ratio mass basis and what is the airfoil ratio molar basis? How you calculate? Airfoil ratio mass, because we need the mass airfoil ratio. You see in the question what it mentioned, determine the stoichiometric airfoil ratio mass. They want mass, not the molar. We know molar, but we need the mass. Okay, is equal to airfoil ratio mass is equal to airfoil ratio molar into molecular weight of air divided by molecular weight of fuel. Correct? What is airfoil ratio molar? It's already there, 4.76A. Now what is okay? I can write down. Then next line I will write down the values. Okay. What are the values? 4.76 into 5. A already we calculate 5. 28.85 is the molecular weight of the air. That should you know. Okay. 44.096. That you should calculate for the our fuel. What is our fuel? C3H8. C3H8 you should calculate what is the molecular weight. That you should know how to calculate. Okay. Now the airfoil ratio with respect to mass basis comes out to be 15.6. Okay. Now let's move on to the next question. Once in a pre-mix layer at the airfoil ratio mass 18:1. Determine the equivalence ratio 5. Now, okay. In this question, first you have to write down what is given. Propane, which is C3H8, burning at an air-fuel ratio with mass basis of 18:1. Okay, what does it mean? It means it is a pre-mixed one. Simple, because it's mixed with the air. Okay, this is a very good question. What does it mean? If some equivalence is given, how you know what is a pre-mixed or not? So this is some air fuel, let's say something given means you know that it will be maybe a pre-mixed mixture. Okay, but you should also calculate. That's why this is also a good question. But maybe sometimes the value exactly equal to the equivalence ratio. So we cannot directly tell. So that's the reason I just take this question. This is a very interesting question. When I calculate, we see this is pre-mixed, but sometimes this value can be also 1, which is also stoichiometric. Okay, so to find here, we have to find phi. Phi, what is phi? Phi is the equivalence ratio. Again, same assumption I will put. C3H8. Okay. So what is the equation for C3H8? Okay, as I am saying that both question are C3H8, so you can also compare very easily what is the difference between those things. Okay, so this is also a very good question. Okay, previously it is phi is equal to 1, that is stoichiometric, but this is not a stoichiometric. Okay, this is the difference between these two questions. The previous question and this 9th one. Okay. Now, what is A? Already mentioned. Now, here I am telling that X3, okay, Y8. Okay, here we assume what is phi. We have to assume that is a phi is for example 1. Because we don't know what exactly the value of phi. So we assume that it's let it be 1 and then we calculate. Okay. So then this is the approach. This is the approach you should know. Then you are now thinking that okay, it's a pre-mixed. So how we know what is the phi value? So how we then calculate further? Okay. So you have to follow this approach. You have to assume phi is equal to 1. This is the only choice you have. Okay. By solving this question, this type of question, you have only there is only one of choice available. Okay. Then I think by putting all these values, I think you get the A value as that is 3 plus 8/4 divided by 1, which is equal to A is equal to 5. Okay. You get the A value now. If you know the air value, now you can calculate what is air fuel ratio stoichiometric. Stoichiometric air fuel ratio you have to calculate, which is 4.76 times A molecular weight of air divided by molecular weight of the fuel, okay, is equal to 4.76 into 5, 28.85 molecular weight of the fuel. Okay. So what is molecular weight of the fuel? Sorry, I just forgot to write down what is molecular weight of the fuel. I have to write down. I already told you for propane what is the molecular weight? The 44.096. Okay, which is equal to 15.6. Okay. Now what is the difference? Now we have to calculate phi. How will you calculate phi? Air fuel ratio stoichiometry divided by air fuel ratio actual. Okay, what is this value? 15.6 divided by 18. Where this 18 come into existence, this is already given. Okay. So from this thing, if you see the 15.6 and 18 are not matching. It's clearly it is not a stoichiometric mixture. So that means what is the mixture is? If you calculate this value comes out to be 0.87. And what is 0.87? This is a lean fuel mixture. Okay. Now here only one thing is given is phi and the fuel. Okay, this is a very good question also. And what we need to find? Okay, air fuel ratio of CH4, not CH4, sorry. No, correct only. Actually, it's written that determine the associated air fuel ratio mass for methane and decane. Okay, it's not only decane. Okay, I just made the mistake here. It's not only decane. Okay, so there is 3 cases are there. Okay, 3 fuel C means 3 cases are there. Okay, so let it be first case. Okay, similarly second case is air fuel ratio with respect to mass basis with C3H8 And third one is air fuel ratio mass basis C10 H22. Okay. Now assumption, same assumption. I already write down these assumptions for many times. Same assumption you have to take, which is air. What is air? Air having 79% of N2 and 21% of what? O2. Now we need to find. Now we have to solve now. Solution we have to find out. Solution you see how we should proceed. How I done the first one, same procedure we have to proceed further for the other ones. Okay. Now first is methane. Okay. Now what is x is equal to 1, y is equal to, because C1 and H4. Okay. So like that. Molecular weight of CH4 also you know, that is 16.043 kg per what? Kilomole. Always remember kg per kilomole is the molecular weight. Okay. Now what is the A value we can get here? X plus y by 4. Okay. But here you have to divide it by what? Pi. Pi, because pi value 0.6 is already given. So don't forget, otherwise your answer should be absolutely wrong. So you should divide by, so then only you get the correct answer. Okay. Which is 3.33. Okay. Now we have to find out the air fuel ratio mass basis for the fuel, which is 4.76 A molecular weight of air divided by molecular weight of the fuel. Okay. Now what the values should be? You can calculate very easily by putting all the values together. Like A is 8.33, already know. What is the molecular weight of air? 28.85. Okay. 16.043. What is this thing? Fuel. What is the fuel? CH4. Okay. These values comes out to be 28.50 kg of what? Air. Why air? Because you are calculating air fuel ratio. Okay. Why kg? Kg because you are calculating with respect to mass basis. Okay. Now second one is our what? Propane. Just directly write down the symbols so that it will be also acquainted with symbols, because most of the times writing name is also very also good, but thing is you should learn how to all the symbols for very higher hydrocarbons you should also know. Yeah. So then it will be very easy for you to calculate and write down the equations first. So for that I am write down so that you will be also familiar with all these things, and you see how easily we can calculate everything, very easily. This is the beauty of combustion. Similarly, I just calculated for the A for this thing, how I calculate for the methane. Yeah. Then again, like that, I again have to calculate the air fuel ratio for it. Okay. You should also understand why all these things I am calculating. I can calculate one and then I can also stop. Okay. Then I will show you why I am calculating all these things. Then you understand, okay, something is, some relations is exist here also. Okay. What is the molecular weight of the C3H8? 44.096. Should write down accurate values, then it will be good. What is the value? When you calculate, the values comes out to be 25.94 kg of air divided by kg of C3H8. Okay. Now for the last one, just left again. It is C10H22. Okay. What is A? For A you need the X and Y. So first you need what is X and Y. Okay. Similarly, X is equal to 10. What is Y? 22. How you calculate A? A is equal to X plus Y by 4 divided by 5. What is X? 10 plus 22 by 4 divided by 0.6. What is the value? 25.83. Okay. Now what is air fuel ratio? Okay. So air fuel ratio comes out to be, write down the formula first. Formula you anyway know, so directly I write down the values because already 2 times I write down. So I think 1 time I only write down. Okay, I think you understand, na? Yeah. So that is enough only. 28.85 divided by 142.284. Okay, what is this 142? This is the molecular weight of the Deccan. Okay, when you calculate all these values comes out to be 24.93 kg of air divided by kg of C10H22. Okay, so what the thing we observe here is that when we calculate the air fuel ratio, okay, so air fuel ratio of C10H22 is less than air fuel ratio of what? C3H8 is also less than, okay, just a second, I just have to shift it somewhat. Okay. Is less than what is air fuel ratio left? CH4. So by you see because of molecular weight, you can see here that which having higher molecular weight having Deccan. So Deccan, because you see what you have in the denominator. So here you see molecular weight is having a very much dominance in case of the air fuel ratio. Keeping other factors constant, that phi is also constant, air is also constant, everything constant. So molecular weight having the dominance. So here we can conclude one thing, that air fuel ratio is inversely proportional to the molecular weight. Okay, that you already know, but you should remember. Whether it is very easy when you are going for any multiple choice question, you don't have to then think or write down the formula. Directly you should do it. Okay. Now we already started late. 8:10 or 8:15 we just go. Okay. whether it will be nearly 2 hours. Okay. Now, in this question, what are the things given? It's a very simple question only. Okay. One mole of alcohol, CXHYOZ. Why O is into existence? Because here, initially we are only dealing with the hydrocarbons. Now, in case of hydrocarbons, now we are dealing with the alcohol. So there should be a OH species. Okay, we know mostly ethanol, methanol, all this alcohol and OH species is there. Okay, some chain element OH is always there. So that's the reason here as well as C and H, O is also, oxygen atom is also present. Okay. Here we write down the generic way of writing all these things we write down. Okay, and then we solve it and then we calculate all those. We have to find out some of the expressions. In this question only some expressions we need to calculate. Okay, first of all I write down what are the things given. Okay. 1 mole of alcohol, CXHYOZ, undergoing complete combustion. Okay, what is complete combustion? Complete combustion means when simple thing you know. Okay, that means there should not be any intermediate species. Okay, what does intermediate species means? That means there should not be any carbon monoxide, or there should not be any carbon atom, or there should not be only oxygen, or only nitrogen oxide, NOx formation. All these things should not be there. Directly we get the carbon dioxide, water, and air. That's it. Or this is or nitrogen, not air. Nitrogen formation is there. Carbon dioxide, H2O, and nitrogen. So this is what called the complete combustion. Okay. This you should already discuss, I think, in the class. So again I also told. So what we have to find? To find stoichiometric balance equation. Okay, and another thing is number of moles of air. Write down. Just a second. I think in this question we no need to go for the generic approach. Okay, because what I understand is that in some problem 12 is there. Okay, in that problem 12, actually in the book I forgot to mention here for problem 12, but in that problem 12 some CXHYOZ is there. Okay, and in that question we have to find out the number of moles of air required to burn 1 mole of fuel. Okay, so that is some kind of some questions are there. Okay, that you no need to worry, because what is the now the question is that we should focus. Okay, so one trick I just now give you. Okay, that you need is that. So this is not required now because it's already done in problem number 12. So I don't need to repeat all these things, because this thing. So problem 12 is not that much important, but because I know problem 12's application is important, So I just only put the problem 13, not the problem 12. Okay. So what is problem 12? From problem 12 these things are given. Okay. So I write down what are the things given so that it will be very easy for you to understand what exactly the thing given. Okay. That is air fuel ratio. Okay. I just directly write down everything over. Just a second. Because here I only mentioned problem 12, so I just write down what are the things from a problem 12 we can extract. Okay, with problem 12 I am not going to solve because that is not that much important. Okay, this I already told, this application is always important. What is problem 12 gives us? Okay. That air fuel ratio, the formula comes out to be, okay, in molar basis is 4.76 times x plus y by 4 minus z by 2. Okay, these are all given. Okay, in the, if somebody doing this question, they should give all these things. Okay, so now how all these things came? Okay, when you do this equation 6a cs, I also tell you the problem 12 everything now I'll tell you, but you have to do it by yourself because this is very simple. I already done the same thing for already many species. This is only for the general formula you need to calculate. Okay, in the previous question I already similar thing I already done. Okay. Now, what you do, simple thing you do, you have to do the conservation of carbon. Then the carbon I think you get x is equal to b, something like that you get. You can see it. Okay. Why I am doing this thing all not required, but still I am doing so that it will be easy for you to understand. Okay. Actually it's not required. And then a, what do you get the a? This value. Okay. A is equal to x plus y by 4 minus z by 2. Okay, because what is y? Y you get as 2x plus y by 2. Okay, so all these things are there in the question. If somebody is setting one question, they only should give this one. Okay, this only should be given. Okay, these all these things I just write down for your understanding. Okay. If it is also not given, I also now tell you. I think you also, if it is also not given, you also now understand. Because I did not tell, I only write on problem 12. That's the reason I all done all these things. Just a second. Now, in the question, we know what is the fuel. C3OH and CH4 here given in the problem number 13. Okay. So we now go just jump to our problem number 13, which is our objective to solve. Okay. Now, what are the things given? Here that I write down directly problem 12 all these things because these are already textbook problems, so that you can easily find out all these problems. So if you have the soft copy also easily available in the net. Okay, so you can easily get all these things, or you can from your library, or you can also take these books also. whatever the prescribed books I mentioned initially. Okay, now we just focus on our problem. What is that things given? C3OH and CH4 are two fuel species is given. Only these things are given. What we need to find out? There is same air fuel ratio of mass basis of CH3OH. Okay, and air fuel ratio of CH4. Okay, now what is this thing called? This is called methanol. Okay, this is what? Methanol. What is this thing? Methane. Okay, so now we just first do for our methanol. Again run the mistake, just wait, no, don't worry, you can catch up. CH3OH. What is X? 1. What is Y? 4. What is X and Y? X is the what? Carbon atom. Y is the hydrogen atom. What is Z? We previously know what is X and Y. Now what is Z? Tell. This is oxygen atom. Okay, that is only the twist in this question. Okay, previously we were doing X and Y. Now we are doing the Z. Okay, that's it. Just you have to now put you have already the formula. I already show you the formula. Okay, or you can derive this formula by your own also. This is not very difficult formula. Okay, you should know how to derive. Okay, that is why I just tell you this thing for your homework. Okay, now just come to our problem. Directly we just write down what is the air fuel ratio. Which is 4.76 x plus y by 4 minus z by 2. Okay, into molecular weight of air divided by molecular weight of what? CH3OH. Okay, now this value is should put all the values whatever we have. Okay, x value 1 plus y value 4 by 4 minus 1 by 2 into 28.85 divided by 32. Okay, what is the value we will get? The value we will get as 6.4. Okay, now second weight we have to go for what? Methane. CH4. What is X? 1. What is Y? 4. What is Z? 0. Why 0? Because here there is no oxygen atoms are exist. Okay. One plus 4 by 4 minus 0. What is the value? Sorry, I have to write down 28.85 divided by what is the molecular weight of a CH4? 16. This value comes out to be 17.2. Okay. Now, for example, we need the comparison. Okay. Here in the write down, what is they asked also comparison in the problem. Okay. What implication does this comparison have? Okay. Means we don't know what is the comparison, what is the implication, all these things. So what we do, we just take the ratio, simple. Okay. Then only understand. Okay, which one is bad or which not bad, which one is higher fuel ratio or which one is smaller, like that. Okay. So now we just take the ratio, air fuel ratio of CH3OH divided by air fuel ratio mass basis of CH4. What is this value? 6.4 divided by 17.2, which is equal to 0.372. What does it mean? 37.2%. Therefore, 37.2% of air fuel ratio of mass basis of CH4 is same as air fuel ratio of CH3OH. Okay, this we can compare and see it. Okay. 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 So on the 14th question, if this question also same, we need to find out the answer. Okay. Now, in this question also same H of mixture we need to find out. Okay. Now, what are the things given? Stoichiometric mixture of iso-octane and air. To find, here 3 weights are there. Okay, 3 cases or 3 questions are there. It's not a one question, it's a very long question. Okay. Probably next 15 to 20 minutes I am thinking to do it, because this is very important question. Okay, this and the next question both are very important. I don't want to skip. Okay, these are very important questions. You should know all these things. So you know I am doing these questions. Okay. Up to 8:30 we'll do it. Maybe 8:30 we close. Okay. I don't know who are there because I am only busy in writing, so I don't know. If somebody is there, you can very easily ask any question. Okay, because I am writing in my iPad. Okay. So this is the first one. This is the third one. Okay. So here, what are the assumptions? Same. N2 and 21% O2. This is the first. Just a second. I forgot to put the air. Now, this is the first, second ideal gas equation. Third, H is equal to HF. Okay. Only. Okay. Why? Standard state condition. Okay. Now, let's go for the solution. Now, C8H18. Where the C8H18 came into existence? Because this is the fuel given. Okay. Iso-octane and air. Okay. What is iso-octane? C8H18. Okay. Now, we just write down our governing equation for the iso-octane and air combustion. These values are already not predefined. This you should calculate and get and directly write down, because already I show you how it should be calculated. Okay. While calculating these values itself is also a question. So that is not our objective. Our approach is to directly solve this question. In exam also, if you want, you can do this approach. Okay. If this kind of question are asked. Otherwise, you should write down all the steps. Now, here some of the values are 0. Why? Because here oxygen and nitrogen are what? I already told, naturally occurring substances. So this is 0 and this is 0. Why also 0? We are already told from the assumption we are only considering enthalpy of formation. So enthalpy of formation for the naturally occurring species are 0. That is very, very important statement. You should remember. Okay. Now, what is this H naught? This value is calculated from the table. and appendix B.2. Okay, I write down everything, don't worry. Okay, I just write down here so that it will be good for you. Directly write down. Okay. H bar of mixture at standard state is equal to NCCAT is 1 into, this is value is already you get from the table, you can very easily get 208,447. Okay, that is kilojoule per kilomole. I am not writing. Okay, last I just write down. Okay, so this you get from the appendix B.2. I don't mention the books, you know the book's name Ashoke. Okay, and the value same value is only minus 208,447 kilojoule per kilomole of mixture. Okay. Now, just a second. Okay. Now, first bit is I think over, kilojoule per kilomole of CH that I already done. Now let's go for the second bit. Okay. Okay. Sorry, first part I just made something wrong. Here, it is not kilojoule of kilomole of mixture. Okay, why? Because here for 1 kilomole of the fuel only we are calculating. So, it should be for the fuel, not for the whole mixture. That mixture now I will calculate. Okay, this is for the fuel. Okay. And this is what we want. You see the first bit kilojoule per kilomole of fuel. Okay. And what is the fuel? Fuel is our C8H18. Okay. Now for the second bit, we need to calculate mixture in terms of kilojoule per kilomole of mixture. Okay, now how is the formula? I already saw this formula many times, so just have to apply this formula and get our answer. Okay, That is summation of xi into hi bar. Okay, bar means that is for mole basis. Now what is xi? Ni by molar fraction, that is Ni by n total. Okay. What is n total? Just add all the number of moles. What are the species there? This we should get from our equation. The chemical formulation that there we can easily get from reaction to product. Now, what is x of C8H18? 1 divided by 1 plus 12.5 plus 47. What does it mean? 60.5 it is we are getting, so what is the value? 0.0165. Okay, very simple. Similarly, we just go for x of O2. Point 2066. Okay. X1 2 how we calculate? Already we have a 2. No need to calculate for the third one because what is the total mole fraction? 1. So from the 1 if we minus all these things, then we can easily get. That is x of n2 equal to 1 minus x of C8H18 minus x of O2, which gives to 0.7769. Okay, 0.7769. Okay. Now, we just have to put in the formula, previous formula, that is x summation of xi hi. Okay. So, if substituting all the values, we get the value as minus 3439.3755. Okay, kilojoule of, here we write down kilojoule of kilomolar mixture because here I write, we already calculate based on the mixture. Okay, mixture molar enthalpy just calculate. what you can see here, okay, we'll just have one more bit, okay, so which is third way. What we need to find out, kilojoule per kg. This is bit tricky, okay. Maybe possible we can solve one more question, okay, and try. Okay. What is this value? Summation of II. Okay. Okay. What is this thing again? We can write down what in terms of weight of mixture divided by molecular weight of mixture. This is already given in the textbook, or we can see in the lectures. So, what is molecular weight of the mixture? Okay, you see here what is the molecular weight you get? 30.26. This already procedure I already done. Okay, because we know what are the species, so all the values already we know. We just have to put the values in the formula, that's it. Okay, now we just have to find out weight of mixture. Okay, which is I think this is maybe the last question, because it's already 2 hours. Already I taking more time, but it's okay for the first class, because I wait for you. Very less people are there, so I just wait for some time. That's the reason I start late. Next time I will start exactly at the time. Whoever join will directly attend the class. Anyway, this recorded thing also will help you. Okay. Now, this is the result you get. This is your final result. Okay. Previously we get the values in terms of kilomole of mixture. Okay. Then previously we get in terms of kilomole of fuel. Okay. So in this way, this question is a very good question. Why? Because in this question you are acquainted with all kind of units. That is the most important way, because unit is most important thing in combustion calculations. So This is a very good question to solve. Try to solve all the questions. Okay. And if there is any doubt, you can ask me questions with that my YouTube channel. Okay, that should be just circulate with you just sooner. You can only search my name in YouTube, Sumit Sagar Hota. It will come. Okay. And if there is any doubt, you can comment over there, or you can ask question and answer forum. Okay, question and answer forum. You can also ask. Okay. Today we start late because because of less people are there, or mostly I think no people are not there. I also till now not know how many people are there. I am busy because I am writing in my iPad. So I till now don't know how many people are attended or not attended, or whoever attended. Till now I don't know all these things. Okay, this is very helpful sections because this whatever the questions I am solving, all are very important questions, and these solutions you know where found. Okay, these are not example questions, or if you also try, there is no solution alone, nothing is available. I solve all these things by my own. Okay, so this is very helpful section if you are coming to this section. Okay, or if you are not coming for any reason, you must ask or must see all those videos, so that it will be very helpful for you. And you can ask doubt, whatever doubt you have, you can very easily come and ask the doubts at least. Okay, I think not attended, I don't know till now. But anyway, this recording section everybody should watch. Okay, which is very much helpful for you during your assignments. Not only your assignments, but also it will be helpful when you solve some problems in the other books. This different kind of turbulent combustion problems. These things are very helpful. Okay, so it's I am just considering broad areas of problems, so which is helpful. From the subsequent class weeks, I just be very much concise, and I will just directly come and start the section. I just till now just to wait for you some time. The next time I will directly come and start the section. Thank you very much for attending this section, or if you are also watching this recording section, thank you for that also. Thank you for giving me this time, and thank you NPTEL for giving me this opportunity. Thank you IIT Kanpur also for this opportunity, and thank you Ashoke sir for choosing me as his TA. I am very much happy, and now on I also do my sections like in a very good pace. Like today's section, I will also proceed, and also I just look for you to ask some question to me also. Okay, and I try to attend and ask some questions to me. Okay. Anything you are having doubt in this section, what I am taking. Okay. I think that that's it for today. Thank you very much for everybody.